All right, let's start with some ball drop truths. So I'm gonna go ahead and drop the ball. Drop the ball. Okay. And we want to be thinking about what's happening as we drop the ball. Well, before we let go, we know that the initial velocity is 0, right? It's at rest, I'm holding it. I let go. And we also know another ball drop truth is that we learned in the previous lesson that when we drop the ball, it's always going to have an acceleration of -10 meters per second.
Per second.
Per second squared, sorry. So again, at the very beginning, our velocity, when we drop a ball, our velocity is 0 at the very beginning. As we drop it, our acceleration with respect to gravity is -10 meters per second squared. So any situation when something is falling in a gravitational field, like where we live here on planet Earth, we infer that the acceleration, we're going to call that g. So I'm going to go ahead and show you the equations again. You guys have seen these before, and everywhere that we had acceleration, we now have the acceleration due to gravity, which is again -10 meters per second squared. We're going to do a few practice problems here, so let's get started. How much time should it take for the ball to fall 3 meters? I'm going to go ahead and do some information mining here. So we're trying to figure out time. We know our displacement is 3 meters. Now it's falling, so we're going to have it be a -3.0 meters. The ball is starting from rest at the very top, so when it drops it, the initial velocity is going to be 0 meters per second. And we also always know that the acceleration due to gravity is -10 meters per second. Oh, squared. That's more. All right, so I come over here and I'm trying to find time. So I need to pick the equation that has all 4 of these variables in it. So I need to pick the equation that has time, displacement, velocity initial, and acceleration. Okay, sweet. So that's going to be this equation right here. So I'm going to go ahead and write that over here. D equals Vought plus 1/2 AT squared. And remember the other day we talked about that amazing little thing? Because our initial velocity is 0, we can just forget about this. So we're trying to find time, so I'm going to try to get this t by itself. I'm going to multiply by 2 to get rid of this. And in order to get rid of acceleration, I have to do the opposite of this, so I divide instead of multiply. So I divide over here, get rid of that. Now, I'm almost done. Oh, and don't forget, this acceleration is the same thing as gravity. So in order to get rid of the square here, I'm actually going to take the square root. So t is going to equal the square root of 2d divided by a. Now I'm going to go ahead and plug stuff in. Square root of 2, and my d was -3.0 meters. And I'm going to divide by my acceleration due to gravity, which is -10 meters per second squared. I'm going to go and plug that into my calculator right now. Your batteries are low. Okay, so the square root of divided by, and I get this answer. I get 0.775. I'm going to call that 0.778. And we're talking about time, seconds. I'm going to talk about these units just for a second. So we have meters up top, which is the same thing as meters over 1. And then we're dividing it by meters per second squared on the bottom. Now don't forget, whenever you're trying to figure out how to cancel units on the bottom, we're going to go ahead and flip them. Okay, so I'm going to take that second squared on the top and meters on the bottom. So seconds squared on the top and meters on the bottom. We cancel that. And then we're left with seconds squared, Miss Moore, but that's not seconds. Don't forget, we have a square root sign right here. Boom. So we're really just left with seconds, which is what we've got right there. A stone is dropped from from the top of a tall building. After 3 seconds of free fall, what is the displacement, y, of the stone? So let's go ahead and write some things down. So it's dropped from rest, so that means my initial velocity is 0 meters per second. And after 3 seconds, that's time. What is the displacement? So it's calling it y. I'm going to call it delta y of the stone. And we also know, don't forget, we always know that the acceleration due to gravity is 10 meters per second squared. So we're trying to figure out delta y. So we need to take a look over here and figure out what equation we're going to use. So this time we've got velocity. We've got time. We're trying to figure out delta y, or displacement, and we have acceleration. So again, we are going to be using this equation to get our answer. I'm going to go right over here. So d equals 1/2 at squared. Okay, and we are trying to find, displacement. So delta y is the same thing as displacement. There's a whole bunch of different names for displacement. There's different ways you can, different symbols you can use for it. You could use delta y, delta x, x final minus x initial. So don't be confused. Just because I have delta y here, it's the same thing as this d for displacement over here. So again, we know that the initial velocity is 0, so we can just forget that guy. And this is an easy one because we can just plug in our numbers here. So we're going to say 1/2. Our acceleration is -10 meters per second squared. And our time is 3 seconds squared. I'm going to go ahead and plug that in here. 0.5. Times that times 3 squared. Okay, and this is great because I get -45 displacement. We're talking about meters here, and this negative here, what does that mean? Well, it makes sense because we drop the stone, which means it's falling. So that negative sign in front of it it gives us a direction. After 3 seconds of free fall, what is the velocity v of the stone? So we're talking about the same thing we did before. We dropped it. We dropped it from up high. So we know that our initial velocity, again, is 0 meters per second. And our acceleration due to gravity is -10 meters per second squared. We have the time, again, is 3 seconds. And it wants to know what the velocity of the stone is going to be after that 3 seconds. So that is velocity final. All right, so let's see what we have here. I'm going to come over here and take a look at my equations. I have velocity initial, acceleration, I have time, and I'm trying to find velocity initial this time. So that means that the equation I'm going to use is actually this one because it has all 4 of the variables that I have and the one that I need to find. So I'm going to go ahead and write that right here. And we know that our initial velocity right here is 0, sweet, so we can ignore that one. So let's just look at our acceleration, which is, so I'll say 0 plus meters per second plus -10 meters per second squared, and then our time was just 3.00 seconds. Boom. Okay, cancel, cancel. -10 times 3 is going to be -30, and then meters per second. Boom. A football game customarily begins with a coin toss to determine who kicks off. The referee tosses the coin up with an initial speed of 5 meters per second. In the absence of air resistance, how high does the coin go above its release? All right, I'm gonna draw a picture for this one. So we tossed the coin up. And it said the initial speed was 5 meters per second. And it wants to know how high, so we want to know the delta y. And of course, we always know that the acceleration due to gravity is -10 meters per second squared. So we only have 3 variables right now. We need at least 4 of the 5. What else do we need? Well, let's take a look at this paper over here. What else do we know about when something is being tossed up into the air? Well, we know it slows down on the way up, it stops at the top, and then it speeds back up on the way down. This right here is the key. It stops at the top. That means that our final velocity is going to be 0 at the top. Meters per second right there. Okay, so let's figure out which equation we're going to use. Well, the variable missing out of these ones is time. So as I come over here, this one is the one that doesn't have time. So we're going to use this equation. I'm going to go over here and start writing this down. Equals that plus 2AD. All right. So I want to solve this equation for delta y, displacement. That's this guy right here. So how do I do this? The first thing I'm going to do is subtract this guy over here. And then I want to get this by itself, so the opposite of multiplication is division. So I'm going to divide by 2 times acceleration due to gravity, and that's going to give me just a d over here. All right, so now I'm going to go ahead and plug this in. So I'm going to say d equals, my final velocity was 0, subtracted by my initial velocity, which was 5. And then I'm going to divide by 2 times the acceleration due to gravity. Okay, and when I plug that in, I can just ignore that. We're going to say, so -5 squared divided by -20. And I get 1.25 meters. Boom. If the coin is caught at its release point, what is the total time the coin is in the air? It takes the same amount of time to go up as the fall back down. So again, I'm going to draw a diagram of this so we can see what's going on. So we throw the coin up in the air, and it actually also, it comes back down this time, and it ends exactly where it starts. We know our initial velocity is still 5 meters per second from the last question, and we know that the final velocity is 0 meters per second. This time, we're trying to figure out what the total time is. So our question is, what is the time? We also always know that the acceleration due to gravity is -10 meters per second squared. Okay. So take a look at this though. The coin is going up in a certain amount of time, and it's also coming down, and it's going to take the same amount of time to do both of those. So essentially, the total time is going to be 2t. So whatever we calculate for going up, t, we'll just multiply that by 2. So we have final velocity, initial velocity, acceleration, time. What is missing? What don't we have? Well, we don't have displacement, which means we're going to use this equation right here. So final velocity equals initial velocity plus a times t. And we're trying to solve for t. So I am going to do the opposite of add, so I'm going to subtract initial velocity. Velocity final minus velocity initial. And then I'm going to get rid of the a by dividing, because we have multiplication right here. The opposite of multiplication is dividing. Divide a, and this gives me t. I'm going to go ahead and plug in my numbers here. I know my final velocity is 0 meters per second, and my initial velocity is 5 meters per second. And I want to divide this by my acceleration due to gravity. that will give me my time. I'm gonna go ahead and plug that into my calculator. And I get, for my time, I get 0.5 seconds. Now, we said that that is how much time it took for it to go on the way up. So what do we need to do? We need to multiply it by 2 in order to get the total time. So that times 2 gives me 1 second.
Boom, boom, boom.
Boom, boom.